Hi and welcome back. This is the second video for section 4.1. 4.1 video number 2. We're still learning about linear functions. So in the last video, we decided how to decide if a function was linear from a table, how to decide if it was a linear function from a graph, and we worked on finding the equation of a linear function given some information. So let's practice a little bit more with finding the equation of a linear function, and we're going to do it this time given a table. So I guess the first thing we should do, it says let W of n represent a linear function, but let's just ballpark check here to make sure we agree that it actually is linear. And then we're going to write an equation W of n. So this is going up by 2 each time, 2, 2, 2, 2, 2, and this one's going up by 3, 3, 3, 3, 3. So I'm feeling pretty good that I understand that this is a linear equation because these guys go up by 2 and these guys go up 3 consistently. So my slope is going to be 3 to 2. Now, if you didn't feel comfortable about the way that I did that computation of slope, you can also make this problem very easy for yourself. And remember that each one of these pairs in this table is also a coordinate on the graph. So if we have the point 2, if W of 2 is 0 right here, this is saying W of 2 equals 0. That means that the point 2, 0 is on your linear equation. And this says W of 4 equals 3, which means that 4, 3 is a point on your linear equation. Well, we just practiced finding the equation from 2 points. Let's do it one more time, but that's really one way you can do this pretty quickly. So let's calculate first the slope. So this is, let's go x1, y1, x2, y2. So that's y2, which is 3, minus y1, which is 0. Over x2, which is 4, minus x1, which is 2. So that's 3/2. We got that from finding our rate of change, but we can compute it that way too. And the second thing we need to do is find our y-intercept. So y equals 3/2 x plus b. Let's plug in to find our y-intercept. We can plug in the first point. So 0 equals 3/2 of 2 for x plus b. 0 equals 3/2 of 2 is 3 plus b. So that means negative 3 equals b. So y equals 3/2 x minus 3. And then the only thing that I want to do now is it did ask me to write this as W of n. So when I put that into function notation, I'm going to write W of n, my input variable, equals 3/2 n minus 3. So if you wanted to work with n and W of n the whole time, that's completely fine. To me, it's easier to just think x and y, horizontal and vertical, and then switch it to whatever notation they want at the end. All right, let's do this same problem from a graph. Well, I'm going to tell you 2 ways to do this. One way number 1, is to pick 2 points off the graph and do it the way we've been doing it. Pick 2 convenient points. Compute as I showed you before. Compute as we did up there. What other convenient points? I see a lot of convenient points on this one. How about negative 3, 0 and 0, 3? Sure, that's way number 1. Go ahead, compute your slope, complete your y-intercept, get your equation of your line. Great. All right, I'm going to show you way number 2 because it's always good to have 2 different ways to do things. I'm going to remember some things I know about linear equations. Well, I know that y equals mx plus b. I know that m is the slope, and I know that b is the y-intercept. Now, not all graphs are so convenient as this one. Maybe the y-intercept you can't tell exactly what it is, but on this one I can, and I can see that the vertical intercept, the y-intercept, is the point 0, 3. So I already know my b value, right? B value is equal to 3. And what is my slope? Well, I already have 2 convenient points marked, and I can compute my rise over my run between those points. So this is a rise of 3 for a run of 3. So rise over run, slope, is equal to 3 over 3, which is equal to 1. So I know my slope equals 1. B equals 3. So now I can actually just plug that right in. Y equals 1 times x plus 3. And usually people don't write 1 times x. They usually just write y equals x plus 3. All right, so there's two different ways you can get the equation of a linear function from the graph. All right, so let's talk about parallel and perpendicular linear functions. Parallel linear functions are linear functions that have equal distance between them vertically, so they have the same slope, but different vertical intercepts. So let's just sketch a picture of what I'm talking about here. If I have coordinate axis and I have, two linear equations on here that have the same slope, they look like a pair of railroad tracks, right? These are parallel linear functions. They have the same slope. Same slope, so m's are the same, right? Different y-intercepts. So the b's are not the same. We can see this one has a positive y-intercept and this one has a negative y-intercept, but the slope is going to be the same. Now, perpendicular functions have slopes that are inverse reciprocals. So we're reciprocals with different signs. So let's see if I can draw perpendicular function. So here's my first function. Maybe my perpendicular function comes down like this, and they intersect at 90 degrees. It doesn't have to intersect on the x-axis. That one just happened to intersect on the x-axis. So their slopes are inverse reciprocals. What does that mean exactly? Well, let's pretend this guy had a slope of a nice positive number. Let's say it's 2/3. If that guy's slope is 2/3, then the other one's slope would be minus, because it's opposite sign, and then reciprocal. Switch the 2/3 to 3/2. Okay, so their slopes are inverses, that means opposite signs, and reciprocals, which means you just take the numerator and denominator and flip them. The rise of the one is run of the other, and the run of one is the rise of the other. All right, let's go ahead and practice this. And of course, these would have different y-intercepts as well. Different y-intercepts. Unless they happen to intersect at the y-intercept. That would be the only time. Usually different y-intercepts. The only time they wouldn't have a different y-intercept is if you happen to get one that like crossed right at like the origin or right on the y-axis. All right, let's practice this newfound information about parallel and perpendicular functions. So let's say we have a linear function f of x equals 2x minus 1. And we want to find another linear function that is parallel to f of x, but also passes through the point 2, 5. All right? So we're trying to find a parallel function to f of x that passes through the point 2, 5. All right, so how are we going to do this? Well, we're going to find our standard things that we do when we always are finding linear functions. We're going to figure out what the slope is, and we're going to figure out what the y-intercept is. Well, how do we figure out the slope? Well, it turns out that the slope is actually given to us. It tells us that it's parallel to this function. This function has a slope of 2, so our slope is also 2, right? Because they're parallel, they have the same slope. All right, and now how do we find the y-intercept? Well, we know our equation so far is y equals 2x plus b. How do we find the y-intercept? Well, we use the point they gave us. So we're going to plug in a point to find the y-intercept. Same process that we've been doing so far. So we plug in 2, 5. So 5 equals 2 times 2 plus b. 5 equals 4 plus b, subtract 4, and b equals 1. So our equation, y equals 2x minus 1. And it'd be probably good to put this in function notation, so we'll just call this guy g of x equals 2x minus 1. How did that happen? Something terrible has happened. I made a mistake. Where did I make a mistake, guys? Because that's the same original function. It can't be right because you plug in 2. You get 4 minus 1 is 5. I made a mistake somewhere. Plug in 2, 5. Oh, it's 2x plus 1. I'm not even going to delete this. It's 2x plus 1. All right, this is a great learning opportunity here. Hang on, back up. I'm not undoing my unmistaking. So I looked at this problem, and I figured I was doing this all correctly. No problem. Everything's great. I'm good at math. And then I look at my final answer, and I realize I got the exact same thing as I got for f of x. And so I'm like, I must have made a mistake somewhere because these are not the same. So the first thing I did is I took this point, and I plugged it into f of x to see if I had made a mistake in the original problem. But 2 times 2 is 4, minus 1 is 3. So this has the point 2, 3, not 2, 5. So I know that I didn't make a mistake there. So now I look back over my work and try and figure out where I made my mistake, and I realize that my b value is positive 1, not negative 1. So here is where I made my mistake, and I can even highlight it. I'm okay with making mistakes. 2x plus 1, as long as you figure out what you did wrong. 2x plus 1 is the correct answer. So, you know, if you make mistakes as you're going along, everybody makes mistakes sometimes. Just go back, work through, and try and figure out where you made your mistake. 2x plus 1. All right, awesome. Now, let's try number 9. Let's consider the same linear function, but this time we want to find another linear function whose graph is perpendicular to f of x and passes through the point 2, 3. All right, so let's give that a try. And we're going to follow the same 2 steps. First, we figure out the slope. Second, we figure out the y-intercept. All right, so I know the slope of the function is perpendicular to, right? So that is 2. What is the inverse reciprocal of 2? Well, we'd like to think maybe 2 is 2 over 1. That helps me. So the inverse reciprocal of 2 over 1 is negative 1 over 2. So that's my new slope, negative 1 over 2. All right, so far I have y equals minus 1/2 x plus b. All right, and now we're going to plug in the one point we know. 3 for y equals negative 1/2 times 2 plus b. So 3 equals negative 1/2 times 2 is negative 1 plus b. Add 1 to each side. 4 equals b. 4 equals b. So y equals minus 1/2 x plus 4. That's my perpendicular function. Let's give this another, let's put it in function notation. We'll call this guy h of x. h of x equals minus 1/2 x plus 4. The slopes are inverse reciprocals. If I plug in 2, hopefully I get 3 out. Yeah, I do. Awesome. All right, let's do another example. And this time we're going to practice a little bit with that different type of notation. Up until this point, it's been 100% slope-intercept form. But sometimes you do see things in standard form. Remember, that's called standard form. Standard form is a constant times x plus a constant times y equals a constant. Standard form of a linear equation. So let's go ahead and practice this one. It looks a little intimidating at first, but there's a quick way to make it not be so bad. What I'm going to do is I'm going to take it from standard form and put it into slope-intercept form. And then I'm just going to proceed as normal. All right, so let's take it from standard form and put it into slope-intercept form. How do I do that? Well, slope-intercept form, remember, y equals mx plus b, so I need to solve for y. So I'm going to subtract 8x from each side, and I'm going to get 2y equals minus 8x plus 3, and then I'm going to divide both sides by 2, the whole right-hand side by 2. Y equals, now this is a part people make mistakes on. Remember, you have to take 2 both into the 8 and into the 3, because this is the same as saying negative 8x over 2 plus 3 over 2, right? You got to be careful. This is probably where the most mistakes happen. So that's minus 4x plus 3 halves. All right, so now I've taken this equation in standard form and I've put it into slope-intercept form. And now finding a line that is parallel and perpendicular to it and both passing through 3, 3 shouldn't be too hard. Let's do the parallel one first. Parallel. Well, what's the slope? Well, it's the same, right? M equals negative 4. The slope is the same for a parallel line. We know a point on the line is 3, 3. So after we plugged in the slope, we had y equals minus 4x plus b. Plug in 3, 3. 3 equals minus 4 times 3 plus b. 3 equals minus 12 plus b. b equals 15. Add 12 to each side, right? So a parallel one, parallel, y equals minus 4x plus 15. All right, let's do the perpendicular one. What's the slope? Well, this has a slope of -4 to 1, right? So the inverse reciprocal of that is going to be positive 1 to 4. So my new slope is positive 1 to 4. And I'm still going to use the 0.33. Y equals 1/4 x plus b, plugging in 3. I'm not scared of fractions. 1/4 times 3 is 3/4. Subtract 3/4 from each side. B equals, well, 3 is the same as 12/4 minus 3/4 is 9/4. So y equals 1/4 x plus 9/4. And if you used fractions, that's okay too. I mean decimals. Decimals are okay too. So if you had written that as decimals, it would be y equals 0.25x plus, is that 2.25? I think it is. 2.25. That's fine to use decimals as long as you're not rounding. So if you're dividing by 4 or 2 or 10, it's great to use decimals. If you're dividing by 3, you're going to have to stick with the fractions. Otherwise, you're going to be rounding, and that's not good. All right, so that's the end of section 4.1.